Hi, my name is Ram Krishna Sharma. I'd like to explain using aggregation functions in relational algebra. So let me go ahead and share my screen here. And I can actually annotate slides, which I think is great. But just to set up the motivation here, we're familiar with SQL and using group by. Group by is a keyword that essentially lets us group things together from an existing table on the basis of something. So you can imagine if I had a table where, let's say this is tracking transactions, and you have multiple names on, let's say, a customer name column, and each name correlates to a transaction in terms of its amount, right? So let's say transaction amount. So if you have multiple customer names and you have multiple transaction amounts, right? I could be on that table, right? It could say Ram Krishna Sharma bought something for $25, and then it could say Cynthia bought something for $42, and then after that it could say Ram again bought something for $28, right? So if you wanted to use group by and you wanted to use an aggregator, or if, let's say if you wanted to create a table that basically just has one instance of my name or your name, and then just the total amount that you've basically purchased at this particular place, then you would say, okay, you want to sum the transaction amounts. You want to group those transaction amounts by customer. So for each customer that it encounters, it's going to sum all of their transaction amounts, and then it will just display just one instance, your name, and then the transaction amount total, your name, then the transaction amount total, your name, and then the transaction amount total. And it will do that in essence for every customer, right? Now in SQL, you would actually use group by, right? Um, you would say, you would say, okay, well, select customer name, and then, comma, and then you would use an aggregation function, like sum, and then we would say transaction amount um, as total bought, right? And then eventually you'd say group by a particular thing. You'd say group by customer name, right? That's how you would do it in SQL. In relational algebra, it's a little bit different. Let's dive into this. So the idea here is that, we're given three tables. And, it's clear here that, we have basically a table of boats, the boat ID, the boat name, and the color. And of course, there are two other tables here, which don't necessarily seem too relevant, but they're here just for illustrating a real world use case. Here it says, consider the following schema statements we have. Write RA to find the number of each of the colors of the boats. So you want to start with these questions by asking yourself, what should the output table be, right? The output table what should it look like, right? Well, if it's saying it wants number of each of the colors of the boats, right? Already to find the number of each of the colors of the boats, right? So you're essentially going to want to have, color here as one column. And then you're going to have how, let's say boat number, right? How many boats actually correlate to that? There's your answer, right? I mean, this is what your output table would be. And the first step is always to say, okay, now that I know what my output table is, we're gonna use the projection to you're basically just listing those off. So whatever you want your column names to be, it's gonna be color and it's gonna be, whatever this is here, boat, boat number, right? Um, and then whatever goes inside here, that's kind of really a concern for later, but this is, you've just found your answer. So when you read the question and then you say, okay, well, what should my output table ideally look like? Well, you're going to have this and this. Okay, well, that my larger statement here, layer one, is going to be pi, and then I'm listing out what I want my columns to be. Whatever goes in there is going to take care of two things. It's going to take care of the group by, and it's going to take care of the summation. But it's just good to say, okay, well, let me start with just basically the simplest outermost layer thing, and then I'll tackle what's on the inside. Now, let me just come up here for just a moment. But the way you do this, right? The way you do this, because look, we're going to have to do a few things here. We're going to have to dictate what to group by, right? In our particular example where I was talking about customers buying things, we grouped by customer. So you only saw one, like each particular customer, Hannah, Rom, Jacob. You just saw those names there and you saw their total amount that they've spent at a particular location, right? Um, and I mean, in the original table, they had multiple instances where they showed up and they correlated to a transaction amount, right? Which makes sense because people buy multiple things at different times. But it condensed all of that into one name and then the total amount that relates to that one name. So, in a sense, um, in a sense, how do we do that? Well, the thing that, you put the aggregation function here, and then you put the name of the table that you want the aggregation function imposed on.
Fella, looks like we brought the cars. Brand new.
So,
Not easy. Where do you get the plan?
so, so that's essentially how you do it, right? Um, so what do you put in? So that's the table that we're working on right now is boats, right? So I'll just say, okay, we'll have boats. But what do you put here? This is where the aggregation function goes. This is where you put the thing that you're saying, oh, I'm grouping by this, right? So we know we want to basically group by color, right? So color is going to go here. And our aggregation function is going to be count of BID. Count of BID because it's interesting. You're basically um how many boats by color, right? So boats are identified by their unique ID. So, you can essentially do this by their unique ID. Um, because only one ID will relate to one boat. So if you want to find out how many boats are gray, you're gonna have multiple boats of different colors, but gray, you want to count how many IDs relate to gray. So you do count BID, right? And that's the idea, right? And that's how you get the inner part. So, put pi first, once you know what your column names are, put those column names down, and then you just have a G here. The thing you're grouping by goes here, and the thing in the summation goes later, and then you have an extra parentheses at the end just to say, hey, you're actually doing a summation on what, or not summation necessarily, but what is this particularly imposed on? Um, Now let's actually go down and do another example. So here, this is kind of interesting. We have two tables, right? And it says, okay, you want to find the average and max loan amount of each customer. So you're like, okay, well, what does my table look like? Okay, well, it's going to have a customer name, and then it's going to have, an average section, and then it's going to have, a max section, right? That's essentially the average loan and the max loan they've taken and a customer name. Okay, so you already know that you're going to be, this is how your table looks like. So essentially, you write your pi, right? And you write your pi, and those are going to be your three parameters, right? It's going to be your customer name, your average loan, max loan. You can name them whatever you want. In the outer, it doesn't matter. Like you don't actually have to like do the aggregation here. You can just straight up name something and be completely fine. But anyways, yeah. So and then that's how my structure looks like right now. I can deal with anything else and everything else later, right? Now, what happens inside here? Well, I know I'll have a G. What am I grouping by? I'm grouping by customer name, right? So I put customer name down here. What are my aggregation functions? Well, I have to do an average on the not the loan number, but I have to do an average on the amount and a max on the amount, right? So average on the amount, max on the amount. And then because I'm drawing something from two tables and those tables exist independently, I can't put one or the other table down. I actually have to put the fact that I'm going to do a join on both of these tables. So loan and borrower, right? So it has to be a join between that because I'm treating this as one big table. If you're assuming that you can just grab this stuff, I mean, look, customer name comes from borrower. The amount comes from loan, right? In terms of tables. So I can't just say, hey, um, I can do that. They're insulated tables, so I need to combine them. So when it comes to the actual table, um, putting down the table part, well, you actually have to do a join, Um, this is the relational tree here, the RA tree. These are not generally too complex, although they can be, but I usually what I do is I just strip off from the end, right? So, you have your first statement. Your first statement usually is everything that comes before the first opening, right? So you have that opening there. Everything that's before that first opening, you kind of just put at the top of your tree. And then it would, then you go a little bit deeper down, right? This one is and that's what you have as the second layer. And then you actually have a join on two tables. So to describe the data sources, you actually have to do a split here. But in essence, that's what we're doing here, and that's how to get this done.